Thank you, George. And good morning, everyone. You go to different conferences and meetings, and typically well-established conferences and meeting, you have, planning what to do over time. But this one is a bit different. It runs off from the conference we organized in August last year. And some of you actually went along, and I'm so glad to see you again, once again. And I was here in April last year as well for a conference and Professor Pai organized. So once again, seeing people multiple times. And I'm showing my support of Hong Kong Polytechnic University by wearing a tie from PolyU, actually. So you notice that. Well, reason being, we only had an idea, and Dr. Lu and myself, we had an idea after the conference, a case conference last year. We had a discussion, very good session in the conference on this topic. And I only made a suggestion to perhaps come to Hong Kong to have a workshop. I mean, it's just an idea. All the work is done here by George and his team and everybody else, and I as well. So I have to say that I'm here to support the group, the efforts, and hopefully it's a fruitful discussion, and so we'll carry on from now on into this year's case in Italy and perhaps further down the track. So the topic, as you can see, is very big. Industry 4.0 and Industry 5.0. Automate or not automate. I mean, you might see the alignments, Industry 4 automation and Industry 5 not automate. There's some alignments in the title, as you might guess, but perhaps it's not a clear cut, as you will see as I go through my slides. So I'll make it very sort of broad, if you like, and maybe a talk which is more thought-provoking rather than anything else. So I hope you take away and to think about it, maybe discuss with your colleagues after the workshop. And so some of the topics are very big and will be continued on for years to be discussed and debated even in the years to come. So what I do is talk about Industry 4.0. I'm sure all of you will be aware of this, and it is perhaps a quest for smart factories, which is perhaps the where Industry 4 should land or should bring benefits and values to society in many ways. As Professor Mann mentions, when you do manufacturing research, you have to do research and so that it can be transformed into industry, into applications, into real benefits in industry. But how to do that? And one of the things that people think Industry 4 should see the outcome of the research is to have factories that are smarter. And I'll talk about Industry 4 and Industry 5, the interplay of these two industrial revolutions. Sort of strange situation we are in right now as we're working on Industry 4 and we have Industry 5. So how do we position ourselves, so I'll talk about that. And interplay is perhaps not the right words, but I couldn't find better words for that. We'll see how it goes. And automation in manufacturing is the final topic. As you've seen the topic of my talk. Again, automation, I don't mean automation in the conventional sense as in Industry 3.0, but it's automation in a broader sense of things may operate and things have autonomy and without involving human being in the processes. And I'll finish off with a few final words. Well, I have to start with Industry 4 because the title suggests I'll start from there. And this is a diagram that people will be familiar with. And you probably have seen this not once, not three, not two times, maybe more than, well, maybe many times. Well, I think people perhaps when people dive into technologies under Industry 4.0, they perhaps tend to forget about how it came about, background of this, and why we do work in this area. Well, I guess the key thing is mass customization for manufacturers. And days are gone, and producing cheaply same products and tens of thousands volumes and millions of parts. Everything is the same, and then so you drive down the cost, make it affordable. But now things have changed, and people all want to have things to themselves. You have something that you have, but nobody else has. And that means you put a lot of pressure, you create a lot of challenges to manufacturers that they have to make sure they meet your requirements. Their system, the factories will be able to produce a very small volume of products. One extreme is one-off and big varieties. And they have to have a quick turnaround, and even further, they have to make sure the cost doesn't go up too much. Otherwise, nobody will buy whatever you make. It's a huge challenge, and this requires factory to be smart. That's why smart factory is perhaps one of the key outcomes of Industry 4, as we see, the technologies brings value to industry. But what is a smart factory? So if you say, look, Industry 4 technologies will, lead to smart factories. One of the things is really to achieve individualized consumer and product manufacturing purposes. And CPS is one of the key technologies. And as you probably have seen this under Industry 4 there, and CPS is highlighted as the key elements in there. The second thing is really you need to make manufacturing systems or factories broadly connected, so that you work as a coherent entity across the border, across different countries. And the cloud manufacturing is one of the methods to make this happen. Sustainability, we've all been talking about this, and it will be only increase in terms of the work in this area. Service-oriented business practices. So manufacturing and services, usually they are sufficiently different, but now they converge. They share a lot of features and traits, and they will converge as we go in the years to come. One of the technology shift for smart factory is really looking at the components in the factory, how you actually control them. If you look at traditional factory, and even it is fully automated, things are normally centralized. So control are centralized. And so effort is to centralize things and to integrate things, to coordinate things at a high level. But now we want to have a system that's flexible. So centralizing systems hierarchies doesn't work well for that. And to make sure that you can easily reconfigure, you really have to have individual machines and robots and systems in the factory have some autonomy, and they can be reconfigured with other elements in the factory. So this components have autonomy and have the ability to communicate with other components in the factory. That has become a necessity, really, for a smart factory to become a reality. So bearing that in mind, so you might say, look, give us an example of smart factories. There are many smart factory examples, and I've been talking about these two examples for for quite a few years. So this one is from Germany. This is a smart factory laboratory in Kaiserslautern. It's a process industry making soap. So the line can produce one-off soap, whatever soap you want. So it's possible to do one-off production. But the key thing here is all the components and sensors, actuators, controllers, they all come from different vendors. That's important, and yet they can actually be put together, and so the system is still flexible enough to meet different customs requirements. So this is a process industry, continuous process, as you can see. And what about discrete components manufacturers? This is another example from the same laboratory. You can see there are 4 workstations. They're sort of mobile workstations, so that they can be moved around. And you probably can imagine there could be many more other workstations. When they put together in whatever layout format, they know collectively what they can do. They require individual workstations to have ability to connect, to communicate with other modules, and then collectively they can perform tasks that these different workstations can, in a way they are set up in the layout. So again, reconfigurability and flexibility is the key here. So I'll come back to this later on. As you can see here, the 4 workstations, there is a machine tools. Will this work? I don't think it will take laser pointer. Anyway, all right. So I've got a machine tool and robot manipulator. All right. And the assembly workstation and inspection workstation. So you couldn't imagine it could be others. So they can be put together in whatever way you want them to be. So coming back to the topic, Industry 4.0, and you can see what we have, what I've explained about examples of Industry 4.0. It somehow tells people, give people the impression Industry 4 has a technological focus. Not looking at CPS, looking at digital twins, looking at data analytics, looking at AI methods, all the others. And because of this, perhaps because of this, I'm pretty sure there are many other reasons. And along comes Industry 5, sort of around 10 years after Industry 4 was introduced. So this is around 2021. So Industry 4, 2011. So about 10 years later, the idea, the concept of Industry 5.0 came about. This actually came from European Commission. They announced funding proposals and the themes around this topic. And it's also around the same times we've seen the need of having some discussions and debates about 2 industrial revolutions happening. So we put together a paper, and myself and Dr. Lu is sitting here, and Professor Li Hui Wang, you probably know Professor Li Hui Wang. A lot of you should have met him, and Birgit Vogelhuser from Technical University of Munich. So we thought of, oh, right, that's right. Okay, thank you. So the paper you can see at the bottom, the time from it was submitted and received to the time it was published and available online. It's roughly about 20 days. If you publish papers in your research career, you will understand how long normally a paper takes to see the lights since you submit it to the journal. So 20 days, and the paper came out. And we're very pleased. But I think what's important is what's covered in the paper. The paper is open access, so it's free. Anybody can download and read it. And because of that, it actually has received a lot of attention. So what I've done is I've gone to the journal websites and actually try to list papers under different sort of criteria. And it's a top cited paper and the most downloaded paper and most popular paper in the past 2 years or whatever. So in among the top cited paper, you can see this paper is listed in there. If you go to the most downloaded paper, I can see is right there as well. So, which means people, having interest and have downloaded the paper, have read it, I hope. And if you click most popular paper, it is listed there as well. The paper has received certain amount of attention, which is the purpose of publishing. Okay, you want to publish paper, you want people to read it, and you want to have discussions around the paper. That's really good. Okay, so because the paper is free of charge and open access, I will not go into the details of the paper. I will only highlight some of the issues and some of the topics that are covered in the paper in relationship to today's workshop. We actually borrow the definition of Industry 5 from this European Commission policy documents. So what is Industry 5.0? Well, it is really to recognize the power of industry to achieve societal goals beyond jobs and growth, to become a resilient provider of prosperity by making production respect the boundaries of our planet, environment, of course, and placing the well-being of the industry workers at the center of the production process. And a very important aspect of Industry 5, the last bits there. So the well-being of the industry workers got to be at the center of all the endeavors of smart factory. So that seems to be clear enough, but it does invite a lot of questions. So I'll go through some of the questions as well. Before I do that, and the paper highlight 3 pillars of Industry 5.0. There's a human-centric feature there, as I mentioned, got to be in the center. There's resilience and sustainability, respecting the boundaries of our planets. So that's Industry 5.0. Now we have 2 industrial revolutions. Industry 4 is perceived as technology driven, and Industry 5 is perceived as value driven. But they coexist, and then people may have questions, and people do have questions. We had questions as well as we were writing that paper. What are the questions? So the questions were laid out at the beginning of the paper, and we have some discussions at the end. We attempted to provide answers to some of these questions, and I don't think the answers by any stretch of imaginations are complete and final. So really it is a starting point for discussions. Hence the workshop today, the workshop is a venue for sharing ideas, for debating topics and looking into the future. A very sort of fitting arena for us for this topic. Questions. What are the questions? First question we put up: To what extent is Industry 4 technology-centric and oblivious of human centricity, sustainability, and resilience? 3 pillars. So the question is really asking people whether Industry 4 is really just technology-driven, ignoring all the others. Second question is, can Industry 4 technologies be used to help realize goals of Industry 5? Do we need to develop new technologies related specifically to Industry 5? Question number 3, is Industry 5 a chronological continuation of Industry 4, one after the other? Just like the previous ones, Industry 1.0, Industry 2.0, 3.0, and 4.0. Is Industry 5.0 similar to all the predecessors? Question number 4, are we living in amongst 2 industrial revolutions or perhaps 1? I mean, it's only 10 years between these 2 terms being introduced. So I'll finish with this final question with my talk as well. So very briefly, I'll just go through these questions and the attempts we've made to try to answer, respond to these questions. Question number 1, for Industry 4, yes, it does have a very clear technology slant. Okay, there's no question about that. We've been talking about different technologies, CPS and digital twins and IoT. But I think it is also fair to say it is not oblivious of human centricity, sustainability, and resilience, which means it does address that, it does mention that. If you look at the document published from Germany, and it does mention these different aspects, and perhaps not the central focus of Industry 4, but it does mention that, does cover that. Well, we seem to agree that Industry 5 is a shift in focus, from individual technologies and to systematic approach. I mentioned I'll come back to this diagrams. I'm coming back to this diagram now, but this diagram is supposed to be a sort of a factory, a smart factory under Industry 4. There's no people here, but well, don't be fooled by this. There are a lot of technologies that have been developed for this smart factory examples, and does support factory, does support workers. Okay, so that you can see barcodes going on different workstations, and operators can actually scan the barcodes, can have access to information of all the workstations, and there are many other ways of assisting workers. Assembly workstations, and Dr. Lu has been working in this area, and how do you actually involving robots and human doing tasks such as assembly tasks, how do you make sure they work in harmony in that environment? So I think we've seen some examples already. Industry 4 does consider the human aspect. Okay, question number 2. Technologies, Industry 4 technologies and Industry 5, do they actually have distinctive sets of technologies? They're sufficiently different so that they can be differentiated among themselves. But there are many ways of looking at it. So you can have a look at the Industry 4 technologies. One of the lists that people tend to quote is this 9 enabling technologies by Boston Consulting Group, and I don't have a slide for that. Some of you perhaps will be aware of this 9 technologies. And Industry 5, European Commission has identified 6 enabling technologies. But if you look at these lists and these technologies, they actually have a lot of overlapping. So they are not that different in many ways. Question number 3, perhaps it's one of the obvious questions easy to get answer to, that is Industry 5.0 a chronological continuation of Industry 4, similar to their predecessors, Industry 1 all the way to Industry 4? I guess the answer is no. I don't think we have Industry 5 because we have realized Industry 4. So we move on to Industry 5. I don't think that's the situation. I don't think we can realize Industry 4 in a space of 10 years. I don't know how many years it will take to really transform the factory environment, to have all the technologies we've developed and you have been developing, see them in the factory floor. Industry 5 complements and extends the hallmarks of Industry 4. I think that's true. So it's perhaps an extension of Industry 4, if you like, rather than yet another industrial revolution. Final question, are we living amongst two industrial revolutions or effectively one? I call that techno-social revolution. Well, I like to think it's just one revolution. You know, we started thinking about advanced technologies, and then we realized, look, we have to look after people in the factory. We might have people in the factory for many, many years to come. How do we make a factory so that the workers and the machines, they come together, they work together happily, and they can be made very productive. They form a coherent and a little society in a factory. So that's what I'm trying to put through to you. There's no point of creating new terms, you know, Industry 4, Industry 5. I think I read somewhere somebody has proposed Industry 6.0. And there are more proposing Industry 4.5, Industry 5.5, whatever. But look, there's no point of doing that. It might be useful to apply for funding using these new terms. But we're doing research, we're doing real research work. So I don't really think that's the way we should go. So what's happening with that line there? So I come back to the final bits of my talk, automation in manufacturing. So it's in a broader term, automation in manufacturing. I think this line is drawn by somebody online. That's right. Yeah, take a note. That's right. Yeah, it proves that people are listening, not sleeping. Okay, automation in manufacturing. So McKinsey did a study about automation in manufacturing. He's trying to look at manufacturing environments. What are the tasks can be automated? So what are the tasks are better not to be automated? And they're saying 64% can be automated. Well, what it doesn't say is whether that 60% include the ones that we have already automated. Maybe it doesn't. So that will save a lot of working hours. Okay, so it does mean a fundamental change to the way the factory runs. But there are questions. No, we come back to my topic at the beginning, automate or not automate, okay? The first question is perhaps, will the trend of increased automation in industry continue in the future? Automation, okay? Until we have factories that run it on its own, lights out factories. Just like cars we're driving these days, so we have driverless cars in the future. I think that's coming, and we're going to see that. But factory, we're going to have people-less factory. Suppose McKinsey does another study of this 20 years later. Are we going to see a different assessments again? Are we going to see maybe 85% of the jobs will be transformed, will be automated, or maybe 90%? Are we going to see that? So this is a trend we need to ask ourselves. Ask ourselves about the time that we may not be around, 50, 100 years later. Will we always see people in factories? Okay, following on to the first question, and so automation must carry societal responsibilities. If a factory have people, and they have to have people in the factory, they do the tasks we ask them to do, we need them to do, then the factory become a mixture of machines and people. And it's like a little society, and how do we respect human in the factory? I think that's one of the key reasons why we are talking about Industry 5.0. That's the second question. Question number 3, how will the techno-social revolution shape manufacturing industry businesses in 20, 50 years' time? So we talk about Industry 3, Industry 4, Industry 5. In 20, 30, 40, 50 years' time, how do we see that? Where does it go? Will manufacturing firms continue to exist as an economic entity or a social entity? Factories, different manufacturers, over the years, I mean, one of the key sort of drivers for factory to exist, to continue to advance, to improve, is making profits. No question about that. You have to make things cheap enough, and it can, it can survive and it can be competitive. But if we have people in a factory, do we need to consider people in there? If the answer is yes, to what extent we consider that? So that's decisions we make, technologies we invest, will benefit people in the factory, workers in the factory. You may compromise the revenue, the profit, but we may accept it because this human-centric approach we're taking. How does AI impact manufacturing automation? So this is the time AI is blooming, and the technologies, research on AI in many years, in the past many years, and people don't see much in the mainstream application. Now is the time we see that. Like or not, you see that, and then we're jumping on that in different volumes and capacity. But how does it impact manufacturing? Where do we see manufacturing go with the continuous influx of AI tools and open AI tools coming online? I want to come back to Industry 4, Industry 5, with human in the loop or not, and things can be automated and things cannot be automated. So if you look at this chart here, the vertical axis representing a task, the tasks in the factory. And then I have industry revolutions on the horizontal axis. And for Industry 4, perhaps the manual work, the manual tasks in the early days, before first industrial revolution, perhaps all done by human, by hands. There's no machines. Okay, but over the time, as we have industrial revolutions up till now, things are being automated. So the more and more jobs and tasks are automated. So hence the graph I've got there. But if you draw a graph about tasks done by machines, automated, and maybe it's just a mirror. And this is a very sort of, this is an indicative diagram. Don't try to to focus on any points on a curve, and doesn't mean much about that. But it's sort of mirrors diagram. It's got to be mirrored, I think. So the tasks that are automated increase over time. where are we at the moment? If you look at the factory, how much jobs works automated and how much are not? So probably you will see somewhere we're here. Okay, Industry 4, both industrial revolutions. But the question is, remember I was talking about the trends in the future. Will the trends of automation for manufacturing continue? It may slow down, but the trends still continue. It may take a long time to automate some of the tasks that we still have human being involved. And will we ever see a day where factories do actually run on its own, and there's no people in the factory? So mathematically, if you try to model this, you might have a point here, but this is perhaps, I don't know, could be next to infinitive. Maybe we will not see that. But again, I'm asking questions. Okay, is a question perhaps nobody can give you an answer. So I wouldn't have the answer. I don't know. This industrial revolution is maybe a 10th industrial revolution. We'll see that or something like that. So that's a graphical kind of a view of my thoughts. So what to automate, what not to automate. In a factory environments, the managers will have to make decisions, and the decisions are based on some of the criteria here. Things need to be automated and things not to be automated. These are some of the tasks. Right now, people think it's better not to be done by machine. You know, let's keep people there doing all those tasks. I won't go into the list, but they all very self-explanatory. I didn't mention about AI for manufacturing. Well, that's coming, and like or not, it's coming. It's really in our eyes and in front of you, and you see that day in and day out. And Deloitte did a survey that, and 96% of the companies believe that AI will have a pivotal role to play in technology shift and growth and innovation. And it can help in many ways, and I'm pretty sure it can help human-centric automation and smart manufacturing as well. And this diagram is showing the areas with AI applications in the companies. You can see, you know, what areas is making a bigger impact. Automation, optimization. A lot of you are doing work in optimization, inventory management, and supply chain as well. I'm a huge believer in that. So it's going to make a huge impact with AI tools in prediction and predictive maintenance and all the others. So it is a general understanding. It is not difficult to agree to these either. Well, human-centric, human-robot collaboration. You've seen this in many places. An example from Volkswagen factory in Germany, a robot is working with humans and doing assembly work and other tasks. So really, you can see the slogan here is no knowledge left behind. So it's knowledge possessed by human workers and operators, and we want to preserve them. We want to make use of them. So knowledge is power, creates values as well. No human left behind. So that's really a societal needs. We need to look after people. We need to take factory workers along with technology advancements. Creating manufacturing systems with enhanced personalized production is one of the drivers of Industry 4. Okay, but really, if you want to make a system flexible, and robust, and perhaps, you know, if you have a human in the system, then really you need tools, AI tools, to give you the power, ability to make that happen, making manufacturing system adaptable and to system disturbance as well. So another question, what is a factory for? Why do we need a factory these days? Well, it might seems to be a simple question, but perhaps you realize it's not a simple one when you dig into these two scenarios. The one to the left is look like a fully automated factories, no people in there, no workers, and the one to the right is human in the system working with the machines. So the question is a factory for economic benefits, or is a factory for social benefits? Okay, you might want to redefine benefits, economic benefits or social benefits, but really one without human, one with human. So how do you really treat factory, this unit? Well, I was thinking, as I was thinking about this, and I came across a paper published last year from this conference. It's published in CD Computer Science. It tried to put Industry 4, Industry 5 in a diagram. So what we have here, so I'm just quoting this diagram from the paper. Horizontal axis is the membership, so people understand the basis of fuzzy logic. You know, so membership there, and to what extent it belongs to a certain class. And then the horizontal axis indicates to the left is everything is fully automated, and to the right extreme is everything's done by human workers. So the diagram looks like this, and the red line is indicating Industry 4, and so to the left is everything is automated. And when it comes to point D, this is the point where Industry 4 does not support human in the loop, a human-centric approach. And then the blue diagram indicating Industry 5, you know, it's one extreme is 100%, everything, people, the membership goes to 100% if you go to further to the right. So when you have two industrial revolutions in Industry 4 and 5, a hybrid situation, and you have this green bell curve in the middle. So this is perceived as where we are at the moment. But the paper falls short to call this as just a single industrial revolution, as I like to think it is. But it does somehow agree to my points. You know, we don't have two industrial revolutions, we only have one, which is, you know, the focus has been shifted somewhat. Okay, so another diagram, this is my diagram. So if you say Industry 4 is what we think it is, and Industry 5, and I think it is, we agree there's some overlaps in there. The overlap space doesn't really indicate the percentage of overlapping at all, but I'm saying these two concepts have overlaps. But really, they got to be seen as one thing. So that's why I'm coming back to one term, techno-social revolution. Maybe there's another paper in the making, talk about this a bit further. So we will see, watch the space. Okay, to finish off, a few concluding remarks. Industry revolutions from 1 to 5, I think we all agree has led to fundamental changes to industry, which in turn lead to changes to the economic and societal consequences. Very important to emphasize societal consequences. which is not right there from Industry 1 all the way to Industry 3, I think. Industry 4 answers call for manufacturing to meet mass customization trends. As one of the drivers for Industry 4, as I explained at the beginning of my talk. Industry 4 needs Industry 5 to be reminded of essential societal needs. I think that's clearly true. Reminded, or perhaps put more emphasis on the societal needs and the value and the responsibility as the ultimate goals. Industry 5 requires Industry 4 for the technological pushes and solutions. So Industry 5 itself will have to have Industry 4 come along with it and providing the technology pushes and solutions. And manufacturing can be seen as a coin with two sides. So I've explained this already. One side it could be seen as the economic entity, I mean the factory itself, and the other side could be a social entity, meaning there's a lot of human aspects and well-being to be considered in the factory. So that's my talk, and thank you for your attention. I can't leave without showing our laboratory down there and the websites, and welcome to visit our laboratory. And the two logos there, one is the website and the other is the virtual tour of our laboratory. If you haven't been to our laboratory, and you can just take a virtual tour and have a look at some of the work we have been doing. Thank you. Thank you for your attention. Thank you.